Hi. To bring together the work we've been doing throughout Theme 8 on geohazards, I want us to take a look at a national case study. A place that has to deal with multiple geological hazards to be able to protect its population and its country. The place we're going to look at is New Zealand. Now, in recent years, we've seen the geological activity and the hazards it poses in New Zealand. There was this eruption of the White Island volcano, killing tourists that were visiting an active volcano back in 2019. In 2011, the city of Christchurch was devastated by a series of earthquakes, which resulted in about 80% of its city centre having to be rebuilt. A generational change in the city. So clearly, New Zealand has some significant geological hazards. Now, we need to think about what might make a place vulnerable to geological hazards like this. Clearly, the tectonic setting has to be a part of it. But there's also other factors. Its wider geology, its landscape, its population density can all contribute to the hazards involved. We also, in other parts of the world, have to think about economic development. New Zealand, though, has the resources to be able to deal with these issues and also, as we'll see, to be able to understand them and predict them. We're working on pages 30 and 31 of our Theme 8 booklets. Because what I want us to do with this is to assess these multiple geological hazards. Trying to piece together our own hazard map of New Zealand. So we've already identified some of these factors that can make a place like New Zealand vulnerable. This map that we're working on, these geohazard regions, show the hazards that apply in different areas of New Zealand. The capital letters shows the major hazards, the lowercase letters, the smaller ones. Let's have a look at some of the factors then that can influence this. While we're doing this, I want you to add some notes to this map. I want you to be piecing together the evidence that we're going to need to be able to come up with our own hazard maps. Let's think about which are most significant first of all. Looking at that map, what do you think? Which ones of these should New Zealand focus most of its attention on? If we look at some of the data, this comes from the Munich Reinsurance Company, we can see that there's a very clear answer. Earthquakes affect pretty much all of New Zealand and pose a very high risk in the vast majority of the country. However, there are others. Volcanic eruptions, tsunamis, storms, floods can be significant in places, even droughts on occasion. So you can see that there's lots for New Zealand to deal with here. If earthquake, though, is the major one, we need to think about what's going on with the plate tectonics. Now, the plate tectonic setting of New Zealand is a slightly complicated one. This is a simplified tectonic map of the two islands. We've got the North Island and the South Island as the main parts of New Zealand. And we've got two plates jostling against each other. To the west, the Indo-Australian plate, and to the east, the Pacific plate. But you can see their relationship isn't straightforward. By the North Island, in the area I've labelled up A on this map, we've got the Pacific plate being subducted underneath the Indo-Australian plate. And as a result, we get the Kermadec Trench and all the geological processes that go with the subduction zone. On the south end of the South Island, we have another subduction zone, the Pussegur Trench. Here, the Indo-Australian plate is being subducted underneath the Pacific plate. In between the two then, the region I've labelled B here, we actually have a conservative plate margin. In New Zealand they call it the Alpine Fault, as it runs through the Southern Alps mountains. But you can see here we've got two different subduction zones and a conservative plate margin, all affecting the relatively small country of New Zealand. So, if I put on the earthquake data, you'll see the effect of this. Around the North Island, we get the increasing depth of earthquakes that we'd expect to find with a subduction zone, going from shallow to intermediate to deep. Running right the way along the Alpine Fault then, we have a whole series of shallow earthquakes, potentially quite destructive. A slightly more complex picture down in the south, but that's perhaps one we need to worry about less for reasons we'll see later. Add some notes to your map. This is clearly going to be an important part of assessing the risks. So let's think about some of these risks then. We've seen where the plate boundaries are. How does that then reflect in the volcanoes? This is a map of the active and dormant volcanoes. You can see White Island marked there on this map. And you can see that the majority of New Zealand's volcanoes are on the North Island. That includes volcanoes like Ruapehu that erupted in the mid-1990s, and also Taupo, now a massive lake, but it's actually the caldera of one of the biggest eruptions ever, a real supervolcano. So clearly volcanic hazards are really a North Island phenomenon. Now, strangely perhaps, there is something that's been missing from this map. You can see we have floods, earthquakes, volcanoes, slips are landslides, and coastal erosion all marked. But there is something that, considering New Zealand's position in the Pacific Ring of Fire, has been omitted. Because New Zealand also has to deal with tsunamis. Tsunamis generated from around the Pacific region that can affect particularly the east coast, as we can see, of New Zealand, but that's also perhaps where most people live. So there are this whole range of different geological hazards. It's perhaps only Indonesia that has to deal with a greater variety of hazardous events. Now, we identified earlier on that population distribution can also affect the risks of hazards. Are these hazards happening in the same place where most people live? If we look at a population density map for New Zealand, you can see that population is densest on the North Island, There are a couple of major cities in the south, Christchurch, Dunedin, but it's the North Island, particularly around the Wellington area, and most of all around Auckland, and to an extent then upper Northland as well. But we can see there are some hazards that affect these areas. Label up your map to show where most people live. Perhaps use an atlas to help you with this. So, we've got these major tectonic hazards that affect New Zealand. Earthquakes, volcanoes, tsunamis. There are others though. New Zealand is a tectonically active area with young mountains, like the Southern Alps. So landslides are an issue. It's a wet place. Rainfall levels in some places are very high. So landslides are going to be an issue. You can see on the Geohazard region map that slips are a minor hazard almost everywhere. So, what I'd like you to do now, using the notes you've made, I want you to, on page 31, produce your own risk map. Where are the areas that you think are at highest risk from these multiple geohazards, which are at low risk and which might be somewhere in between? Use a colour key or a shading key to show what your idea is. Remember, these though are your ideas. What's your interpretation of this? There's no one right or wrong answer to this question. If you finish that, have a go at digging deeper. Okay. Press pause now and have a go at that. Okay then. I hope by now you've got a good sense of where the biggest risks are and crucially why they're there. Let me show you this map. This is a United Nations organisation that has produced a hazard map for New Zealand. These are where they've identified the greatest risks, particularly from earthquakes, but also from other hazards that are here. You can see they've identified the area, in particular at the southern end of the North Island and the north end of the South Island, the area sort of around the capital of Wellington, as being perhaps the area at greatest risk. That's where we get a combination of the sea, steep land, and this conservative plate boundary. The risk from earthquakes there, as well as from storms, combines to make a very high risk area. It seems in some way a daft place to have located a capital city. But there we are. How does this match your map? Have you considered other risks to be greater? Do you feel that the greater population, for example, in the Auckland area, means that area actually is at higher risk from the multiple hazards that we find here? It's a fascinating place, and it has to be said, a very beautiful one. As a case study, though, it shows us how different geological factors can combine to create hazards that do need to be managed, that do need prediction, preparation, and education to minimise their effects. If you have any questions, I'll see you in class.